This is Linear Applications Part 3. And in this one, we're going to be doing the same stuff we did in Part 1, except the equation's not given here. So we have to take this information and use what we already know from forming the equation of a line, which is to find the slope and then the y-intercept, or to plug it in our point-slope form. So let's get started. So the record for the 1,500-meter run was 3.85 in 1930. 20 years later, the record stood at 3.70 minutes. So these are not rates of change. These are not slopes. These are fixed points. And what we have to do first is locate what the whole problem is about. And it's about the record for the 1,500-meter run. And then we got to pick a letter for that. So R for record. Sounds good to me. And we're looking for mx plus b. So it's y equals mx plus b. This is our y value. So since these are fixed points, when we make them, it has to be 3.85 for the y coordinate and 3.7 for the y coordinate, because that is what the whole problem is about, the record. Alright, so these are our minutes. And the other thing we have here is years. So this is one coordinate. It's a fixed point. And this is the other fixed point right there. So we have to turn these into points. I want to go here. Since we know that it's 3.85, then we have to put a value here. So we could put 1930 if we want. And then it says 20 years later. So we'd put 1950. Now here's the option. We can use 1930 and 1950. Or we can do this. We can use 0 and 3.85. And then we would use the 20 and 3.70. Either one are going to work, but I like this better because they're smaller numbers. So now when we plug in time for here, it's the years since 1930. So if you want to use 1980, well, that's 50 years, so you'd plug in 50. Okay, so that's why this one's 20 and that one's 0. So 1930 is 0 years from 1930. And 1950 is 20 years. So now that we have 2 points, we now just need to find our equation. So the first thing to find is our slope. So we have 3.85 minus 3.70 over 0 minus 20. And that's 0.15 over minus 20. Let's plug that in our calculator. 0.15 divided by 20. So it's minus 0.0075. So that's our slope. And what does that mean? Well, our rise here is minutes, and this is years. So this means we're going at 0.0075 minutes per year. So it's saying the record for the 1,500-meter run is decreasing 0.075 minutes per year. Okay, so now we need our y-intercept. So if we plug in our slope, which is negative 0.0075, we pick either of our points, which is this one. So we plug in 0, plug in 3.85, which is the record, plus b. Then our b equals 3.85. This is the other reason why I like converting it to 0. This is now our y-intercept. So I didn't even have to plug it in. I could have just said y equals negative 0.0075. And then are we going to use x or t? I think I'm going to use t for time. Plus 3.85. And there's our equation of the line. So if you read it, it's saying the record is decreasing 0.0075 minutes per year. And in 1930 it was 3.85. That was our initial time. So let's answer some questions. So use the line to predict the number the record is in 2002. So we have to subtract 1930 to find the number of years, which is 72. So if we plug in 72 into our calculator, so I can just put a negative on that, times 72 plus 3.85. 3.31. So in 2002, the record should be 3.31. The only way to figure that one out is to actually go online and check it. But there it is. Okay, let's answer some more questions. If the trend continues, when will the record be 3.10? So we take our formula again, plug in the record, and solve for t. Calculator. So 0.75 divided by 0.0075. 100. In 100 years. So the record should be at 3.10 100 years from 1930. So we take 1930, we add 100 because that's what our t is number of years. Where did I write it? Time is years since 1930. So if we have 100, that would be 2030. So in 2030, if this trend is linear, the record should be 3 minutes and 10 seconds for the 1500 meter. Okay. Last question is the slope. So now you have this formula. What does our slope mean? So where we go back up, and I wrote it on there, we did minutes over years. So this is minutes per year. And then we go back and read with the whole problem. It's about the record for the 1500 meter run. So we say the record for the 1500 meter run is decreasing 0. And the reason I put decreasing is the negative 0.0075 minutes per year. Okay. The y-intercept was 0. and 3.85, and that's minutes. Remember, this is always the initial, our y-intercept, and our initial year was 1930. So in 1930, the record for the 1500 meter run was 3.85 minutes. And that's everything. Now these are very complicated. They're not quick. They're not easy. They will take time, and you really have to sit here and think about them and what you're actually doing. It's recalling how to form an equation, and then once you make the equation, you have to make sense of the equation to answer all of the questions. So take your time, relax, sit down, have a cup of coffee, and just practice. So this one may take you a while, and that's fine. If it takes you an hour, then it takes you an hour. But give number 6 a try. Hit pause now. So if you need a little help getting started, the whole problem is about Biff's computer value. So these are your y coordinates. So I put them here and here. And it says after 4 months of use, right there is 4, and then after 10 months of use, it's 10. So neither of these is a y-intercept. You're going to actually have to find the y-intercept. But the first thing you want to do is find the slope. So hit pause and try. So this is what you should have gotten for the equation. So the value of Biff's computer is decreasing $80 per month with an initial value of $14.20. Alright, try part B. What's the slope? Well, let's just do it together. It's minus 80, and I wrote the units on there. It was dollars per minute. That's what we subtracted. So it's dollars per minute. So the value of the computer is, and since it's minus, we have to put decreasing. Decreasing $80 per month. Can't even read my own writing. It's minutes, it's not minutes, it's months. There we go. And then the y-intercept is 0, 14, 20. And again, the whole problem is about the value. So that number is dollars, dollars, dollars. All right. So initial value, you can even say purchase price of the computer was 1420. That's it, because it's initial, so you write initial. All right, what was the original cost of the computer then? 1420. And if you don't know how to do that, we take our formula and initial would be 0. And there it is. So even if you forget, just plug in 0 when you want original. How long will it take for the computer's value to drop to $100? So you plug that into the formula. $16.5. And there it is. So in 16.5 years, not years, months. Everything's in months. 16.5 months, his computer will be worth $100. That's it. So 16 and 1/2 months. And that's it. So when you start the formula, to create a formula, you need 2 points. Create the slope, find the slope, plug it in to find the y-intercept. It gives you an equation. Remember, every number that you have here, you can kind of think of them as whatever the problem is about. So it's the value of his computer, value of the computer. And this is a decrease in value per month. And this is the initial value. That's our word problem. And so the one that we got here, our revenue formula, that's the decrease in the record for the 1500 meter run per year. And that's the initial one, which was the 1930. That's it. Thank you.